Hello students. We had seen in the last lecture one example, okay, based on the ideas of what rotating frame, and we have seen that how do we identify or how do we find out and how do we mention the direction of what the centrifugal force, Euler force, and the Coriolis force. So now guys, I'm going to take few very good problems from Erode only, okay, and I think those few questions will solidify your concepts on these ideas, okay, that we have discussed in these last few lectures. Okay, so guys, let me take the problem number 2 for you guys. Okay, this is from Erode problem 2 guys, and this is actually the question number uh, 1.115. okay, so this is the question actually. So guys, it is given like this way that a small body, okay, a small body of mass m, okay, of mass m. 1 minute guys, I think this one I think first I want to take this 113. It's a bit simple, so let me rectify this. Okay, this is 113 that we are going to take first. Okay, and then we will come to 115 again. So guys, this is said like this: a horizontal horizontal smooth rod AB rotates with a constant angular velocity angular velocity omega, that is 2 radian per second 2 radian per second about a vertical axis, about a vertical axis, passing through the its end A, passing through the its end A. Okay, a freely sliding sleeve, a freely sliding sleeve sleeve of mass 0.5 kg 0.5 kg moves along the rod moves along the rod along the rod from the point A from the point A with initial velocity 1 meter per second 1 meter per second. Question is saying find the Coriolis force acting on the sleeve. Coriolis force acting on the sleeve sleeve in the in the reference frame fixed to the rotating rod fixed to the rotating rod at the moment at the moment at the moment when the sleeve is located when the sleeve is located at a distance at a distance at a distance r is equal to 50 centimeter from the rotation axis. Okay guys, so guys, see, this is a problem. Of course it takes a lot of time for writing the question, guys. Next time I'll just make the figure. I'll dictate the question verbally, but along with that, in parallel, I will make the figure. Okay, so I think we can save a little bit time in that. Okay, so guys, let's see this problem. If you want to try, you can try. Okay, it's a simple problem, and let me solve this question for you. Okay, so let's see, guys. Okay, so if you see, guys, here in this case, if we draw the figure, guys, okay, if we draw the figure will look like, if I show you the, guys, what top view. Okay, I'm just showing you the top view also, and guys, I'm going to show you what the side view also. Okay, so guys, if you see, this is your axis, okay, which is coming out of the plane. Okay, and let's say the rod is rotating like this, omega, with 2 radian per second anti-clockwise, and the sleeve, guys, okay, the sleeve is somewhere here. Okay, has been reached from the axis, and this distance is given how much, guys? 50 centimeter. Okay, it has been given, guys, what? 50 centimeter. And if you see, right now they have asked what would be the Coriolis force, and when the particle was, guys, what actually this sleeve was when it was here. Okay, just let me use some other color so that you can differentiate this. So guys, if you see, when the sleeve was here, okay, when the sleeve was here, at that moment, guys, it was having velocity of how much? 1 meter per second, guys. And of course, when it will be here, guys, it will be having some other velocity, and that would be what, guys? The v rot, if we are sitting in this rotating frame, guys, if we are sitting in this v rotating, sorry, in this rotating frame with having angular velocity of what? 2 radian per second, then this velocity is going to be what, guys? Our v rot. Okay, in that case, so guys, to find out v rot, we have to do some basic math. Okay, so guys, if you see in this case here, if you see the acceleration, okay, guys, anything else? I think yes, the mass is given how much? 0.5 kg. Okay, mass is given 0.5 kg. Okay, and anything else? I think no, nothing else is there, guys. Okay, so guys, first we have to find out what the v at this instant. Okay, so how do we get v at this instant? That we have to understand, guys. So if you see, guys, in this outward direction, there is, if I am sitting in this frame, guys, I am going to observe there is some acceleration in the outward direction, and this outward direction, guys, this acceleration will be coming because of what? Only one force, and that is what, guys? That is centrifugal force. Okay, centrifugal force will be what, guys? The force that we have to apply in the outward direction, because in terms of real forces, guys, there is no real force that is acting in the horizontal direction. Okay, only mg and the normal force are, guys, which is acting in the what, guys? Downside of the plane, the mg would be acting, guys. Okay, and upside of the plane, guys, there would be a normal force coming from the what? From the rod, guys, would be acting. Okay, so these two forces are the real forces, guys, but these are vertical forces. In the horizontal forces, there is no real forces. Only, guys, if I am sitting in this rotating frame, I am going to observe one centrifugal force that is acting in the outward direction, and that force would be what, guys? At any general distance r, let's say when the particle was, guys, here, and the distance was what, guys? R. At that moment, the force, guys, that would be acting on the body in the horizontal direction, okay, or in this radial outward direction, will be how much, guys? That will be f f outward, guys. F outward will be m omega square r, guys. M is given, guys, omega is constant, so, guys, a outward, okay, a outward that you are going to have is, guys, what? Omega square r. So, guys, what we have to find out? We have to find out the v when it has reached to what? 50 centimeter. Okay, which is what? 0.5 meter, let's say. Okay, so, guys, what we can say, a we can write as what? Omega, 1 minute, guys, sorry, it will be what, guys? V dv by dr is equal to what? Omega square r. Omega is constant, guys. Okay, so what we can write? We can write v dv is equal to omega square r dr. Now guys, if we integrate, when r was, guys, what, 0, okay, then guys v was what, 1 meter per second, okay, and when r is what, guys, 0.5, then v is something, okay, let's say. So guys, let me solve this first. So here, guys, what we got v square by 2, and the limit will be what, guys, v, and this will be what, 1, and guys, omega square will come outside, r square by 2, guys, we will be having here r square by 2, and limit will be what, guys, 0.5 here, and this will be what, guys, 0. So guys, 2 will be what, cancelled out. If we put finally, it will be v square minus 1 is equal to omega is what, guys, 2, so this will be 4, and guys, 0.5 square, that will be what, guys, 0.25 minus 0. So guys, it will become v square is equal to what, it will become 1 plus 1, guys, 2. So v is equal to what, guys, at that moment, root 2. Okay, so v is what, guys, root 2 at that moment. So guys, if we have to find out the Coriolis force, so guys, we got v root, guys, we have found out that is what, root 2, seen from the what, rotating frame, guys. Okay, so if we got v root, we can directly write, guys, the magnitude of Coriolis force will be what, the Coriolis f Coriolis will be what, guys, it will be minus, if you want to write like this, guys, so minus 2m omega cross v root. Okay, so guys, here the answer would be what, f Coriolis will be minus 2m. Guys, direction, I think we will specify later. Okay, I'll just write down the magnitude. Direction we can write down later. Okay, so guys, just magnitude. Okay, so magnitude will be what, guys, it will be minus 2. Guys, mass was what, 0.5 kg, so half omega is given, guys, 2, and v root is how much, guys, root 2. So guys, if you see 2 to cancel, it will be what, it will be 2 root 2 Newton, guys, in negative. Okay, of course, the direction we can find out, guys. Okay, so further, if you want to put the values, guys, also you can write 2 into 1.414, so this will become 8282, so around, guys, 2.8 or something like this way we should get the result. Okay, so I think, guys, that is the answer for this problem. I hope this is clear to you, guys. Okay, so I hope this is settled, guys. Okay, now coming to the next problem, guys. Okay, I hope this is settled. You can go back. Okay, if any step you did not got like clear, so you can watch the video again, and I think you can understand this. Okay,